Thanks, everybody. I forgot your name. Steve, as Steven said, I run my own little technical consultancy, but we can sort of dive right into it. To me, the biggest and most interesting thing and the biggest innovation, I think, in the OpenStack space these days is how OpenStack gets deployed. So who here has actually deployed OpenStack? A couple of us, right? So most of you don't even know this pain. You don't realize the problems that you get to avoid because of the changes that have happened these days. So we're going to talk about why it's hard. We're going to talk a little bit about how containers help us fix that. But we're also going to point out that containers are not the entire solution. There's actually a little bit more that you need. So we're going to talk about these things. So why is it hard? First off, OpenStack isn't one thing. Many of us maybe have actually deployed an application before. That application may even have a couple of moving parts. Like maybe I need a database and a web service, and I can bring those two things together. I can manage that. When I suddenly realized that to get a basic OpenStack system running, I need at least 5 different applications. Those applications have at least a half dozen moving parts each. There's a real problem that gets created by that sort of system. And then on top of that, it's usually not just the 5 applications. It's a number of additional aspects that I also want to implement. I want to understand things like networks and my storage. All these pieces have to come together to make a harmonious OpenStack system. And that's a pretty complicated task. A couple of years ago when we were doing this, it would usually take you about 2 days to get a stable running OpenStack system up and running. As of about a year ago, I think we were able to get that down to within a day. Usually 2 or 3 hours, you'd have enough time to pull all the pieces together, and that would get you a stable system. Now, if any of you have actually run systems for any period of time, what's the very first thing that happens as soon as you have a stable system? It crashes, right? You have a bug. I need to fix the bug. What do you need to do? Oh, I'll just update that piece of the code. Problem is that updating one piece now affects these dozens of resources, all these systems that are involved. And that's actually the biggest problem with deploying an OpenStack system, is just that potential for crashes, potential for failure, and the recovery of that. So that's great. So we have a problem that we want to resolve. So how do we look at this? Well, first off, if we can package things better, right? If we can make it easier to put all the pieces together that we need to have a running piece of the system, right? So we have Nova, our compute entity. If we can actually bundle all of the Nova bits together, then maybe we have the potential to say if I need to upgrade Nova, I can replace that bundled bit. It sounds like a pretty compelling option. If I want to upgrade something, if I have a better model for managing those upgrades, managing what information is being applied to my resource, my system, that I will actually find will really help make the system much more efficient. And lastly, I always say the KISS principle, keep it simple, stupid, right? I mean, that is really an important aspect of a lot of this. I've seen so many OpenStack systems fail, not because they didn't actually manage to get the system running or even manage to find a way to upgrade their environment day after day, but in reality, they had so many complex components that they were trying to integrate at the same time that their system would fall apart just because one microsystem would fail on them. Right, so keep it simple. I don't necessarily need the open virtual switch if all I'm doing is attaching a couple of network segments into my environment. Right? If I need to do some real custom path management in terms of my network service, yes, I might need that complex system, but let's keep with simple systems when possible. All right? So better packaging, a model for upgradability, and a simpler system if possible are really sort of the key things that I can do to implement a more stable OpenStack environment. Now, I can do this with the standard model, even starting with source code. For the one person who deployed OpenStack here, and I think a bunch of you joined, I had asked earlier, has anybody deployed OpenStack? And one person raised their hand. Anybody else open, a couple? Okay, now we've got a couple of folks that have actually gone through this pain then. The thing that I found though is that, containerization really changes the game. Firstly, containers, in this case we're specifically talking about Linux process-based containers, are a way of bundling all of the resources that a process needs together into a separate Linux kernel namespace, effectively. And there's actually a couple different technologies that go into it, but we're trying to get all these pieces together in one specific domain. And by bundling it and then turning that bundle of resources into an image, I can now move that image around and I get the exact same utilization, the exact same capabilities every time I deploy that image. Right? The nice thing about this is that I've segregated that process, those resources, from all of the other processes. So if I change something within that process, it doesn't affect the other systems. Actually, it still can, but in most cases, it doesn't affect the other systems. And I can change other systems and not affect my current running state. These are really important aspects of this. But this whole containerization concept still doesn't mean that I have something that looks like a virtual machine. It's actually very lightweight. I have built VM-based OpenStack systems where every service is its own virtual machine. That works, but it's a very heavyweight approach to doing this. I actually consume a lot of excess resource because I usually don't have super fine-grained control over the size of my individual virtual machine. Right? In the containerization model, because I'm basing this on a process, not a virtual machine, I'm sharing the resources potentially across multiple containers without having to be very hard-coded in saying, oh, I'm going to give you exactly 1 gigabyte of memory and one of my cores out of my 20-core machine. Right? I can say, well, I'll share those 20 cores, I'll share that gigabyte of memory, and if you don't need it, that's great. If you do need it, you can still get access to it because you're sharing from a much larger pool. So the containerization process really helps in making the system a little bit lighter weight. For those of you that have tried OpenStack on your laptop, often you end up trying to run all the processes on one machine. Well, you can do that in 4 gig. If you try to do that as separate VMs, you end up with a need for about 40 gig of systems memory just because each individual virtual machine wants its own. Right? So you've already seen the potential benefits of containerization, even if you didn't deploy as containers. Right? So we want all these things. We're also, we're going to use a container engine. Actually, the guy previous to me talked about one I hadn't heard of called Singularity. But in general, we're usually talking about Docker or maybe LXC as the container engine. And this is the thing that actually is launching our containers. It's managing the container processes. But we also need another piece of the puzzle, which is an operating environment. Often, we're not looking to deploy OpenStack on a single machine. We want to deploy this on multiple machines. And that means that we probably are trying to implement some form of resiliency, some form of high availability in our environment. And a container operating environment can help us with that. So, containers, process segregation, right? This is really what containers do. And in doing that, they pull all of the pieces that I need for that particular process to run. Now, the model of containerization that I tend to use for OpenStack deployments is the Kala model. So there's an OpenStack project, you know the project, but this is an infrastructure project rather than a deployed, a tool that you would deploy. It's a tool that helps you deploy. But I'm going to actually containerize each of the individual processes. So the Nova API, right, RESTful endpoint for Nova, is a separate process from the Nova scheduler, which is a separate process from the Nova conductor. And I'm going to put each of these into their own container. Right? And in doing so, if I need to update the Nova conductor code, I don't have to touch the Nova API service, I don't have to touch the Nova scheduler. This is incredibly powerful because each of those resources, especially in the OpenStack space, they're all based on Python. Each one of them doesn't include just its own application, it includes a set of libraries, and if I upgrade one of those components, often I've upgraded some of the libraries as well. Library upgrade failure is the #1 reason why an all-in-one OpenStack system often breaks if you try to upgrade one piece of the puzzle. Right? So by containerizing this, by saying, this is the process, this is its set of libraries, I'm going to put it into its own process space, I'm going to build it as its own image and wrap all those pieces together, that's the biggest benefit that containers give us in terms of simplifying the process of A, deploying OpenStack, and B, then migrating or upgrading those individual pieces. Right? Install time is another interesting aspect. Because I have these images, but I don't have to actually download all the individual process components. I don't have to download 20 different Python libraries or check that those 20 Python libraries were downloaded every single time I install the next piece of the puzzle. Right? So this is a classic problem with a lot of the systems. If you've ever used something like an Ansible or a Puppet or a Chef, you'll see that a lot of time is spent saying, yep, that system is still okay. I actually already installed that piece of the puzzle, I don't need it again. Or often you install a newer version of something and suddenly it says, oh, well, all these things are wrong, so I'm going to change all of them, and I break everything else. Awful, awful way to deal with things, but it certainly is what happens. So our uptime or install time is reduced just because we're aggregating all these pieces together. Now, often I'm pre-building the images, so maybe I'm cheating here a little bit because it often takes 3 or 4 hours to go and build out all of the different individual container images. Why is that? Because I'm going through the exact same install process I would otherwise use. But the interesting thing is that once I have a decent set of container images, as long as I'm building a standard system, I don't necessarily have to go rebuild them. Most of the OpenStack systems that I deploy today are actually using the Docker Hub-based images that already exist. There's a set of Okada images out there so that you can install OpenStack. I've seen it in best case with a good network connection happen in about 20 minutes. That's a completely night and day shift between what happened in the past. In the past, to deploy OpenStack, like I said, best case scenario was 3 hours, getting all the pieces working. So the containerization has really sort of changed this whole thing, and the lifecycle management has changed as well. because of the way that a container image works, I can have multiple container images on the system, and I can say which one I want to have running. So that means that I can actually have a current version running. I can install the next version without running it. And then when I want to, I can just flip the two, stop one process and start another. Now, if you've done that with virtual machines, stopping a virtual machine usually happens pretty quickly. But you're still sort of stopping the entire operating system. You're stopping the entire set of processes that sit behind that, right? If I stop a container, it's stopping a process. Usually that happens instantaneously. If I start a container, guess what? Basically the same thing happens. There's very little additional overhead in starting a container when compared to starting a process. Now, if that container actually has to do some startup work of its own, yes, that still has to happen. But often you can start and stop containers within seconds. And that means that I can actually upgrade something, do a quick test, hit an API endpoint, for example, see if that upgrade worked. And if it did, I continue run. If I didn't, I can potentially roll back to the previous version because both systems are on disk at the same time. Right? Again, containers really help manage the entire process of deploying and running OpenStack. So it's a huge change. Unfortunately, containers don't answer all of the questions that we have. Containers answer that sort of packaging and process management aspect, but often I have the requirements of having some form of scalability to my system. So usually I'll deploy three controllers, three separate physical machines to actually run my system. I'm also going to potentially want to do some kind of high availability. I want to be able to flip back and forth if a process does crash, if a container does crash on me. I want to be able to start that process over again. I also want to redirect my traffic to the other systems. So in order to do that, the container world has seen this as a problem. The container world is focused mostly on sort of web scale applications anyway, and in a sense, part of OpenStack is like a web scale application. So I can actually use tools that provide that high availability and scale. And in this case, Kubernetes is the tool that most people today have gone after to answer this question. Now, there are others out there. There's things like Docker Swarm. There are actual operating systems that are specifically built around the concept of containers that embed tools like Kubernetes or Swarm. But the Kubernetes one seems to be the one that the OpenStack community, at least, has had the most focus on. There are actually 2 projects that are using Kubernetes right now to help install and manage OpenStack. We support now with this Kubernetes model, which is another overlay, and we also have people that say, well, maybe you deploy Kubernetes and then OpenStack, and then anyway, don't need to get into that. But the real point here is that we support sort of the distribution of our components, and Kubernetes now handles the fact that I have a container image that supports, for example, the Nova API. Maybe I want to have 3 of those running, and I want to have them on 3 different machines. Kubernetes is the tool that actually manages that distribution of resource. Kubernetes also has embedded in it, because it's a very standard requirement, the ability to support a high availability load balancing resource. So I can send traffic to any one of those API endpoints or all 3 of them in a round robin sort of fashion. All right, so Kubernetes helps me with that piece as well. I also have a way of dealing with storage. So often I need to have persistent storage. I mean, we have a SQL-based database in our OpenStack system to store information like the number of virtual machines I'm currently running, where they exist, all the sort of system state exists. I need some persistence there as well. Containers have a way of dealing with persistence, but it's usually locally bound. Right, so that container sees a local set of disk space. With Kubernetes, there are models for supporting distributed storage and integrating that distributed storage into the container environment very efficiently. So I actually can get through that. And I also have a model for networking that has been simplified. Remember I said, keep it simple if I can, right? So there's a simple networking model, and that works even with all of the SDN-like networking services that an OpenStack system can deploy. So from a control plane perspective, Kubernetes handles a lot of these aspects. So we fixed a lot of the problems by going to Kubernetes and some form of containerization. Today, that seems to mostly be Docker-based containerization. There is one more piece of this puzzle, and it's not specifically Kubernetes, but it's sort of focused on Kubernetes. In OpenStack, there is a template model for deploying an application called Heat. Right? And if you're deploying lots of applications or very consistent applications, like I'm going to deploy WordPress over and over and over again, I would actually probably build a Heat template to do that in a standard OpenStack environment. In the Kubernetes world, the tool that sort of came out that does this is Helm. And Helm just describes all of the different services. So I want to have the Nova API running, I want to have the scheduler running, I want to have the conductor running. Sort of describes all those components in a format that you can then use to talk to Kubernetes and launch all those individual services in the Kubernetes way. Right? So these are the tools that we find that we're using. When you look at the big picture, the services that have all come together to sort of help make this happen, and this is not the only set, this is just the set that I tend to use, sort of builds on a number of different OpenStack projects. OpenStack Kala project is sort of the root of all of this. And it's actually sort of gone through sort of a bit of a morph as well, but there's the basic Kala project. Its whole focus is just building these containers, taking the OpenStack software, whether it's already been prepackaged in RPMs or Debian packages, or just using the source code and bundling all of that together. Then there's the Kala Ansible project, which looks at using the Ansible systems management tool to actually install and launch those containers. So even without Kubernetes running, I can actually use Kala and Kala Ansible to get a multi-node OpenStack system running. But I don't get all of that other Kubernetes goodness. I don't get the scalability, the management of those processes on remote systems. All I get is a running system. So I'm sort of back to where I was about a year ago in terms of the capabilities of our environments. Kala Kubernetes now takes that one step further and says, well, look, let's take all of these resources, we'll describe them in charts. That's the Helm worldview of a heat template equivalent. And with those service charts, we'll now have all the pieces put together to actually launch a Kubernetes-based OpenStack system. And with all of this, of course, we're going to continue to keep things simple. Now, there's one piece missing, right? Because I have Kala Kubernetes that's deploying my OpenStack. What do I need underneath that? Anybody? I need Kubernetes. So how do I get my Kubernetes running? Right? So there's always going to be this one problem. I have to get some base system running in order to get all this wonderful fanciness to happen. It turns out that there are projects to help make that happen as well. Kubernetes is, in a sense, a simpler infrastructure layer. It only looks at containers. It does tie into storage. It does tie into networks. But in the Kubernetes space, there are a number of tools that have come out specifically to just get your basic Kubernetes environment running. And I've seen a lot of people look at deploying a simple 3-node Kubernetes environment specifically to run OpenStack, and then let OpenStack take care of everything else. So the only thing that Kubernetes is doing in this particular environment is running the OpenStack service. Now, of course, then people will immediately say, well, I would like to have a Kubernetes for my application because I like all this containerization, the application stuff sounds good. So then you have people deploying Kubernetes on top of OpenStack that's sitting on top of Kubernetes. Eventually, there's bare metal in there somewhere. This is not serverless. You know, we still need servers. It's all a good thing, right? So I think that was really sort of the thing. We know that enterprises need containers. Like I said, as soon as you deploy OpenStack, somebody's going to say, can I have Kubernetes, please? Right? So they're going to ask for it. But we still need these individual resources. We still need the underlying virtual machine resources. Right? So even though I think Kubernetes is a fantastic tool, I think OpenStack is a fantastic tool as well. And I think we're going to see the two of these sort of merge over the coming years because the two fit very well together. They support the modern next generation enterprise workloads, and having an OpenStack system running underneath the covers still gives you that current environment, whether it's bare metal services that you still want to implement and sort of manage through this programmatic interface, or the classic virtual machine models that we've sort of come to know and love, I think, over the last couple of years. We have all those resources. So we're going to see Kubernetes both under and over OpenStack and really making the entire system easier to deploy and giving us better programmability. So thank you. You can get a hold of me. I've got lots of information. Yeah, let me know.
Thank you very much. Any questions? I will pass the microphone around, so please wait till I get to you.
Hey, what's the most common and easiest storage protocol to deploy within containers?
So within containers, so Kubernetes provides a way of talking to storage, which is a persistent volume model for storage. Under the covers there are something like 15 or 20 providers already. Turns out there's also an OpenStack Cinder provider for Kubernetes. So deploying something like NFS or deploying an iSCSI-based storage solution are the two that I've seen the most work on.
I know both NFS and iSCSI, but what's the most prevalent?
NFS.
NFS or iSCSI?
NFS. Yeah, because
Any particular reason?
it's easy. No, I mean, seriously, it's easy. And again, most application developers don't have hard and fast storage requirements unless they're in the database space. Once you move into the database space, then iSCSI becomes more prevalent. But most container applications, they're looking at storing, image files or something else that doesn't necessarily have a performance aspect to it. And NFS is a very easy solution. There are lots of open source tools, plus many people that are doing this in an enterprise case at least, often have some form of enterprise grade NFS service available to them too. So it's a pretty common way. And it's a very simplistic tool because you can actually implement NFS in the underlay under the Kubernetes environment without even having Kubernetes know that it exists, right? Okay.
How does using containers change the complexity of patching, say, for example, when OpenSSL comes out with a new library to do a bug fix for a security issue, and you have to patch all of your web-facing containers.
Sure.
Does OpenStack make that easy with Kubernetes, or is it more complex? Or
well, I would say that there are a couple of different pieces. So if you've containerized your application, right, the process that you go through, there are a number of different tools for doing this. Again, in this particular space right now, Docker seems to be the most prevalent utilized container engine. The Docker build process is very simple. You describe a very simple set of steps that builds out your container. And updating that to say, hey, there's a new library that I need. Basically, I was using OpenSSL version 1.2, now I need 1.3 to fix a bug. You'd basically just update that file, rebuild your container. That creates now a new container, right? Distribute that container, and there are a number of different ways of doing that, either a public registry, private registry, or just manually moving the containers around. Get them onto the systems where that needs to run, and then you can migrate to that newer version of the container. Kubernetes even supports rolling upgrades of those newly created container services. Right? So that's the model that the OpenStack community is working towards. Now, the Call a Kubernetes project hasn't yet implemented an update process, but they've set up their environment, the Helm charts, to simplify that rolling upgrade process over time. Right? Okay. There's one more question if we have time.
What networking stack are you using inside Kubernetes?
So Kubernetes has a very simple model. There are a number of different stacks available, but the Kubernetes model is that all pods, which are an aggregate of containers, have to be able to talk to all the other pods. So as long as you have a layer 3 connectivity between all your resources, you can use a layer 2 tunneling technology like Flannel or Weave are the most common there, or you can use a layer 3 technology, and there I think Calico is the most popular. I happen to work with a company called Ramana that has another L3 technology, but those are the two simple models. And the key here is that Kubernetes is basically providing that L3 capability on a pod by pod, e.g. container by container model, and providing that L3 endpoint. Whatever you have underneath the covers then is very simple to deal with because it's outside of Kubernetes environment. Okay.
We have plenty of time for a bunch more questions, so if anyone has anything they'd like to ask, put your hand up.
No? All makes sense. It was so easy and clear, right?
So there's going to be some natural chicken and egg problems. So there's going to be some natural chicken and egg problems that you'll have because it's like, well, how do you first provision the physical nodes and then throw something like Atomic or CoreOS
Yeah.
and then deploy Kubernetes managed nodes and then worker nodes to then get the APIs for OpenStack. And so how do you solve that chicken and egg problem? Do you kind of just sort of force it initially and then fix it later? Like which one do you deploy first?
So the models that I've seen, I've done most of my deployments recently with just the Kala Ansible components, so just containerizing OpenStack, not yet adding the Kubernetes layer into the system. That's a fairly new extension to the environment. And what I've seen is that getting a base operating system up and having enough capability in that operating system to launch Docker, which is the next piece that you need. There aren't that many operating systems yet that support Docker other than Atomic or CoreOS, sort of out of the box. Once you have that piece installed, and we're using things like Cobbler or, principally I think most people are still using Cobbler for that. There are some other tools, some newer tools that are coming along. Red Hat's Foreman is one. There's another company that I work with called RackN, the Crowbar guys from the early OpenStack days. They have a provisioning tool that's another sort of lightweight cobbler-like tool. So getting bare metal provisioned, I don't think is as big of a problem as it used to be. Discovering the bare metal, dealing with all of the intricacies of making sure that your storage arrays are set up and your networks are attached appropriately, there still is a lot of complexity in that first layer of the infrastructure. But that has to happen regardless of how you get OpenStack installed or how you would like to get OpenStack installed, right? So once you've dealt with that problem, and again, there are a number of tools, and I'm happy to talk to you more about them afterwards. Once you have those pieces in place, then the next step often is Puppet, Chef, Salt, or Ansible deploying Kubernetes in the Kubernetes model, right? Or making sure that you have a running Docker system if you're just going to go with something like call Ansible, right? And then you can use Ansible to do the rest of the deployment. And it's actually pretty straightforward. I have some simple environments to deploy Ansible-based environment into a set of running machines. I often do this in some other cloud provider, right? Because I don't have my own OpenStack system just floating around. So I deploy the systems, I run Ansible, and basically just by describing the target machines and what their role is supposed to be, I can actually create a running OpenStack system. Beyond that, the only thing I really need to often provide is some kind of network information. What's the virtual IP of the Horizon and or Keystone endpoints, right? So what IP am I going to be using and sharing amongst all the systems so that I have one way to talk to my OpenStack system, especially if it's distributed. Beyond that, most of the other pieces, a tunneling technology for the network service in the OpenStack world at least is a fairly straightforward thing to add on top of the system. And I have a running system. It's pretty simple.
So then how do you manage the full life cycle of more hardware, less hardware in the future? You want to retire them, bring new ones,
So most
patch
of that,
them?
yeah, I mean, most of that you can do through a couple of different pieces. One, there is still that bare metal management resource, right? Some people have actually looked at getting a single OpenStack system, right, the triple O model, right? Single OpenStack system that can manage bare metal. So now you have an API-driven engine that can manage all the rest of your bare metal. Yes, that piece may atrophy over time. It may become older and cruftier, but if it's all it's doing is making sure that bare metal is deployed and pointing it to a provisioning resource of some nature, then that's pretty straightforward. If I want to deprovision a resource, Kubernetes has tools for helping me do that. One of the reasons that so many people are saying, hey, Kubernetes is probably the right container management tool to manage a distributed system like OpenStack. So now I can start to deprovision some of the resources. I can do the same thing with Kubernetes. There are APIs for saying, hey, take this node out of production. Potentially even, if possible, if there's an underlying shared distributed storage, move those containers out of the way, right? So there are tools for actually enabling that entire end-to-end life cycle. I wouldn't say it's perfect yet, but it certainly is getting a lot better.
Got time for one more question? Anyone else? No? Okay.
You get a second time.
I just wondered if you tested it with the Ansible when you're not running Kubernetes, if you tried it on a lower levels,
Yeah.
like runtime, so like containerd and runst instead of installing Docker engine.
I haven't gone that far. The pieces should work. The Ansible code does expect the Docker daemon, so it is actually looking for Docker as its endpoint, and that's just because of the Ansible code that's currently running to launch the containers at the end. I haven't tried with just containerd at this point though.
Okay, cool.
All right, thank you so much, Robert.
All right, thanks.